So we're going to look at the properties of similar triangles. And right now we've got two triangles here, which as you can see I can move one outside the other. And we're going to set this so that each side of this triangle is, so we've got this length is 6. So this situation here, I know that if I was to move this triangle away and mark this as a 6 here, and this one as a 4. So if I move this back in now and make sure it's the midpoint, then I also know that this side here will be 6 and this side here will also be 4 because I've made it the midpoint. Let's just do that again, and if I move it away the red and blue follow with me, so I don't really want that. But in essence what I'm saying is that this whole length here will be 12, twice 6 is 12. And this whole length here will be twice 4, which is 8. Now I can move this triangle back in. We have similar triangles. Why are they similar? Well, because the angles all add up, all are equal to each other in the triangle. That's why it's similar. So we know that we've got 6, and this is also 6 here. And we've got 4, and we've also got this one is 4 here. So we've got similar triangles. So what we say, the ratio of the lengths of two triangles is equal to 1 to 2. Because we've got one triangle that's worth a length of 4. If I bring this triangle away now, of course the writing comes with it, it's not good. And we've got a triangle of so similar lengths are 6 to 12. So ratio 1 to 2. On that very basis, the ratio of the two different areas will be 1 squared to 2 squared. So the areas become squared. In this case, it will be 1 to 4. So for instance, if the ratio of lengths for a certain similar triangle is 1 to 3, the ratio of areas would be 1 to 9 squared. If the ratio of lengths was 2 to 3, then the ratio of areas would be 2 squared 4 to 3 squared 9, 4 to 9. Okay, so it works on a squared basis. So in this situation we know that this side equals this side, that side equals that side, so therefore we can determine the two triangles are similar. If we had this was 2x plus 1 and this was 100, what we would know that if these sides down the side are in the ratio 1 to 2 because we've got midpoints, then this and this would be in the ratio 1 to 2. So you could say 1 over 2 would equal 2x plus 1 over 100. The same ratio would exist between those two sides. Cross multiply, 1 times 100 is 100, and 2 times 2x plus 1, which is going to be 4x plus 2. 100 equals 4x plus 2. Subtract 2, we get 98 equals 4x, and x will equal 24.5. This question here, we're given that this is the midpoint, C is the midpoint of AE, and B is the midpoint of AD, and we're given the area of triangle ABC equals 10 centimeters squared. And we've got to find the area of triangle ADE, which is the big triangle. So if we look at these two figures, we know that triangle ABC and triangle ADE are similar because the angles are all equal, because we've got midpoints C and B are midpoints of D and A. Therefore, these two lines will be parallel. Therefore, we've got similar triangles. Therefore, this angle will equal that one by corresponding angles. This one will equal that one by corresponding, and this angle up here is a shared angle. Therefore, we've got three angles the same. As long as we've got similar triangles now, we know the ratio of sides, ratio of lengths, is going to be 1 to 2. Therefore, the ratio of areas, we square both of those numbers, is going to be 1 to 4. So therefore 1 over 4 equals, now 10 is the small area, so that will correspond to the top of the fraction over x. Cross multiply, 1 times x is x, 4 times 10 is 40 centimeters squared. So this question here, we're given that C is the midpoint of AE, and we're given that B is the midpoint of AD, and we're given the triangle ABC as an area of 7. We're trying to find the area of the pink region. So we know the ratio of lengths, equals 1 to 2, because we've got the midpoints. Therefore, the ratio of areas equals 1 to 4. So therefore we can work out the area of the big triangle. We know that the 7 is the small one, so therefore the big triangle will be the x. Cross multiply x equals 28. So therefore area of triangle ADE equals 28 centimeters squared. So the shaded area will be the 28 minus the 7, which equals 21 centimeters squared. So we've got a triangle ABC and segment AD. Now segment AD becomes a median when it is the midpoint, point D is the midpoint of BC on that baseline. So now AD equals a median of a triangle. So a median is defined as the line from one vertex to the middle of the opposite side. So therefore, as long as BD equals DC, this triangle is cut into two in terms of area. So the area of triangle ABD equals the area of triangle ADC. And therefore, if ABD was 10 centimeters squared, this area, then this would also be area 10 centimeters squared.